So today we're going to look at Lesson 5 from 8th grade Unit 7, Exponents and Scientific Notation. And before we start with that, we're going to look at exploring negative and zero exponents. So what I want you to do, you can either in your journal or in your red folder, draw this table that you see right here. So in that first line, we've got 2 to the 4th. If I expand that out, that would be 2 times 2 times 2 times 2. And if I evaluate that, that would be equal to 16. And then 2 to the 3rd would be 2 times 2 times 2. If I evaluate that, that would be 8. 2 to the 2nd would be 2 times 2, which is 4. So looking at this pattern, 2 to the 1st would be 1, 2, and it has a value of 2. So based on these observations, let's finish out the left column. What belongs here? We've gone from 2 to the 4th to 2 to the 3rd to 2 to the 2nd to 2 to the 1st. What goes here? 2 to the 0 power. And then after that, we would have 2 to the negative 1 power, 2 to the negative 2 power, and 2 to the negative 3rd power. So what on earth would that look like if we continue that pattern? We talked about a little bit in that last lesson about how 10 to the 0 power would be 1. So looking from here to here to here, what operation is happening when we go from 2 to the 4th to 2 to the 3rd to 2 to the 2nd to 2? From 16 to 8, we divided by 2. From 8 to 4, we divided by 2. From 4 to 2, we divided by 2. So to get to 2 to the 0, this is just another proof. 2 divided by 2 is 1. Okay? So we can say that anything to the 0 power is 1. But what about these negative exponents? That's new. So we just continue the pattern of dividing by 2. So if I have 1 here, what's 1 divided by 2? 1/2. What if I divided by 2 again for 2 to the negative 2nd power? 1/2 divided by 2 would be 1/4. And for the last one, divide by 2 again. 1/4 divided by 2 would be 1/8. There's another way you could express those. 1 over 2 to the 1st. We could write this one as 1 over 2 to the 2nd, which is equal to 1/4. And the last one we could write as 1 over 2 to the 3rd, which is equal to 1/8. So we're going to repeat this table for 3, 4, and 5. So this is 3 times 3 times 3 times 3. It's 81. 3 times 3 times 3, that's 27. 3 times 3 is 9. 1 3 is 3. So this is 3 to the 0, 3 to the negative 1, 3 to the negative 2, 3 to the negative 3. It's kind of hard to see there. 3 to the negative 3. I think I made it worse. Okay, so from here to there, we divided by 3, divide by 3, divide by 3. So to get 3 to the 0, that'd be divide by 3 again. So 3 divided by 3 is 1. Again, anything to the 0 power is 1. 3 to the negative first, divide by 3 again. So that would be 1 divided by 3 is 1/3. Here we could divide by 3 again. 1/3 divided by 3 would be 1/9. We could also write that as 1/3 to the second. And then for the last one, divide by 3 again. So that'd be 1/27. And we could write that also as 1/3 to the 3rd power. For 4, four times 4 times 4 times 4, and 4 times 4 times 4, and 4 times 4, and just 4. That's 4. So from here to there, we're dividing by 4. So to get the rest of the table, we're going to divide by 4 here. So 4 divided by 4 is 1. Anything to the 0 power is 1. Divide by 4 again. That'd be 1/4. Divide by 4 again. That'd be 1/16, which we could also write as, oops, just kidding, it's supposed to say 1. 1/4 to the second. And then the last one, if we divide by 4 again, 1/64, or we could write it as 1/4 to the 3rd. So 5 to the 4th would be 5 times 5 times 5 times 5, which is 625. 5 times 5 times 5 is 125. 5 times 5 is 25, and 5 is 5. So each time here, to start at the top and work our way down, we're dividing by 5. So to get the rest of the table, we're just going to keep dividing by 5. So 5 divided by 5 is 1. Anything to the 0 power is 1. Divide by 5 again. That'd be 1/5. Divide by 5 again. That'd be 1/25. We could also write that as 1/5 to the second. And then the last divide by 5 one more time, and that would be 1 over 125, which we could write as 1 over 5 to the third. Look at the row in each table that has a 0 as an exponent. Describe the pattern that you see. Okay, if you haven't heard me yet, anything to the 0 power is 1. And that's it. So based on that description and what we've just answered there, what is 62 to the 0 power? 1. Look at the rows in each table that has -1 as an exponent. What pattern did you see there? Okay, did you notice that if we had 5 to the -1, that became 1 over 5. When we had 4 to the -1, that became 1 over 4. 3 to the -1 was 1 over 3. 2 to the -1 became 1 over 2. So what would happen if we had 23 to the -1? What would that be? If you're thinking 1 over 23, you would be correct. So look at the rows in each table that has -2 as an exponent. So when we had 2 to the -2, we had two options. We had 1 over 4 and 1 over 2 to the second. When we had 3 to the -2nd, we had 1 over 9 as an option. We also had 1 over 3 to the second as an option. When we had 4 to the -2nd power, we had 1 over 16 or 1 over 4 to the second as an option. So based on this, what we've just looked at in those patterns in number 25, what would happen if we had 8 to the -2nd? Couple of options that you could have here. You could have 1 over 64, or you could have 1 over 8 to the second. Both of those are the same. We could accept both of those. Looking at the rows in each table that has -3 as an exponent, describe the pattern that you see there. So when we had 2 to the -3rd, that was 1 over 2 to the third or 1 over 8. When we had 3 to the -3rd, we had 1 over 3 to the third or 1 over 27. When we had 4 to the -3rd, we had 1 over 64 or 1 over 4 to the third. So based on that description in problem 27, what would you say 6 to the -3rd would be? So you could have a couple of options. You could have 1 over 6 to the third, or if you evaluate that on out, you could have 1 over 216. So to the red folder, solve each equation mentally. 100 divided by 1 equals 10 to the what power? The x's right here. So we're trying to figure out what the x is here. So what makes 100? What power? 10 to the what power? That would be 2. All right, 100 divided by what makes 10? 100 divided by 10 would make 10. What divided by 100 makes, what's the value of this? 1. So what divided by 100 makes 1? 100. 100 divided by 1,000 makes 10 to the what? If you simplify this, 10 to the what power makes 1/10. If you think about what we've just talked about, that would be to the negative first. Okay, so here we've got negative exponent table. And we've got exponents, and we've got decimals, and we've got fractions. Oh my. So using the exponents, we've got a very similar table to what we've been using. 10 to the third, 10 to the second, 10 to the first. So what goes here? 10 to the 0, and see, it says that's 1, and it says that's 1. So 10 to the 0, we've established as 1. That would be, if we continue this pattern, 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. Okay, so 10 to the third is 1,000, 10 to the second is 100. There that is right there. 10 to the first would be 10. So we could write that as 10 over 1. We could write this as a fraction 1,000 over 1. Okay, so going this direction, we've gone from 1,000 to 100 to 10 to 1. What are we doing here each time? Dividing by 10, dividing by 10. If we're going this direction, dividing by 10. So let's keep the pattern going. Divide by 10. So 1 divided by 10 would be 1/10. And if I write that as a decimal, 0.1. I got my fraction and my decimal in the wrong place. Sorry. Okay, so if I continue that pattern, divide by 10. They've already given us the decimal there, so 1/100th. If I divide by 10 again, there is 1,000th, and there's 1,000th as a fraction. As you move to the left, so that means if you go this way, and if you look up at the top, it's got it going this way, you multiply by 10. So going this way, they multiplied by 10. That's what those little dots mean. But if you're going this way, what's the multiplier? So they want us to not divide by 10. They're wanting us to say we multiply by what? What's the inverse of dividing by 10? Multiply by the fraction 1/10. So multiply by 1/10. How do each of these multipliers affect the placement of the decimal? Okay, if you're multiplying by 10, the decimal moves to the right one. If you're multiplying by 1/10, the decimal moves left one. Space. Use the patterns you found in the table to write 10 to the negative 7th as a fraction. So I would write that as 1 over 10 to the 7th. Use the pattern you found in the table to write 10 to the negative 5th as a decimal. So if you wanted to continue the table from up here, where we have 10 to the negative 3rd, 10 to the negative 3rd was 0.001. So 10 to the negative 4th would be 0.0001. So that's 1/10,000th. 10 to the negative 5th would be, move it one more time, 0.00001, so 1/100,000th. So write this fraction using a single exponent. Use the patterns in the table to write 10 to the negative n as a fraction. So 10 to the negative n would simplify to 1 over 10 to the n. Follow the exponent rules, match the expressions that describe repeated multiplication in the same way. So this is a power of a power right here. And that one goes with that one. Alright, so then we got to deal with all of this negative exponent business. So there's that one. We've got 10 to the 2nd repeated 3 times.